Hello, ninth grade. This video is about parallel vectors. So we're going to start out with investigating a little bit. Please, in your notebook, date it. For me, this is the 28th, and this is parallel vectors. Notice that I have glued a strip of graph paper in my notebook. I used about 10 spaces. So please pause the video and either create vertical lines in your notebook so you have graph paper, or tape or paste some graph paper in your notebook. I'm going to start by writing down these four vectors. A is 2, -3. Notice the notation I am using. You are welcome to use whatever notation is comfortable to you. Okay, so once you have those vectors written down, let's look at where they are on a graph. I'm going to start with A. This is right 2 and down 3. So when I start here, I go right 2, down 3. This is my vector, vector A. Now vector B is also going to go right, and it's going to go down because of the -6, but it will be a larger vector. So starting here, to the right 4, 1, 2, 3, 4, 5, 6. There is my vector B. Now looking at vector C, if I start here, I want to go left 3 and down 2. 1, 2, 3, 1, 2. So there is my vector C. Vector D, this is going to go to the right and up. So I want to make sure to leave myself some space in my graph to move up. So I'm going to start down here. I'm going to go to the right 3, but then up 2. And this is vector D. So now looking at those four vectors, ask yourself these questions. Are any of these vectors parallel? Are they perpendicular or equal? Which ones? I will tell you there are no equal vectors. Although C and A and D look about the same size, they're not in the same directions. So equal vectors have to be the same size and same direction. So there are no equal vectors in this image. Parallel vectors. What you should see is vector C and D traveling generally in the same rate of change. And you should also see that A and B are traveling in the same direction and the same rate of change. Two of vector A's will complete vector B. Let's move forward. Here is another picture of those four vectors. Notice vector, I'll highlight them. Vector A was blue, and that's vector A right here. Vector B was red, and that's this whole long vector. And then we had vector C, and then vector D. And notice they all form a nice right angle right here. There's my box for that right angle. So these two vectors are perpendicular to these other two vectors. And we'll talk about that in another video. Just to remind you, what does it look like to have parallel and perpendicular lines? So parallel lines will never meet when they're on the same plane. So what we're going to do now is verify that that vectors A and B are parallel. If they are parallel, they have a value that multiplies to one of them to equal the other one. So what we're going to look at is specifically verify parallel vectors. So vector A, which was 2, -3, and vector B was 4, -6. Well, A is parallel to B if there is a K exists such that K times A equals B. I forgot my vector arrows. So what we're looking for is this K. What is this scalar multiple? So what we're going to do is set up some equations. That means 2 times K is equal to 4, and -3 times K has to equal -6. Now we do one step to find the K, and what we're going to see, divided by 2, divide by 2, over here we divide by -3, divide by -3. Although the operation that we're undoing is different, we still get 2 for that constant, that scalar. And over here, -6 divided by -3 is 2. So this proves that they are parallel. You are also welcome to look at it a different way. Feel free to look at these presentation notes. You could also work backwards and find that the common scalar is 1/2 if we looked at the constant multiplied to the larger vector. This K is 1/2 because half of this larger vector is the smaller vector. The last example, also here you can see that vectors C and D are also parallel. Feel free to look at that example. Now we're going to prove that two vectors are not parallel. So we're going to show that vector A is not parallel to vector C. So start by writing down vector A and vector C. Okay, so if they are parallel, we're going to assume they're parallel and show that the constant is different. So we're going to start with K times 2 has to equal -3. And K times -3 has to equal -2. And when we divide by 2 here, and over here divide by -3, we get two different K values. We see that K is -3/2, but that's not the same as the K over here. which is a negative divided by negative, is a positive 2/3. Negative 3/2 does not equal 2/3. So vector A and vector C are not parallel. Oh, I'm sorry, you can't see that. Go. And so this is why, because that scalar multiple is different between the components. For the x components, it's negative 3/2. For the y component, it's 2/3. Those have to be the same for them to be parallel. Just like up here, they were parallel. If you would like further examples of parallel vectors, or to see a picture of parallel vectors, think about physics. And there's a couple other images. Also, Dr. Megginson, the mathematician we studied after Indigenous Peoples Day, he is a mathematician that studies vector fields. And so here's a picture of what he does, examines. If you are wanting more practice, feel free to look at the additional video posted for practicing parallel vectors. And there's also solutions to this practice at the end of this slide. Thank you for watching the video.